The oracle bones are considered invaluable artifacts over 3,000 years old. These bones, typically consisting of ox scapulae or turtle plastrons, bear inscriptions of various hieroglyphs. In ancient China, diviners used these artifacts extensively. They would inscribe questions to the deities on the bones, ignite a fire, and place the ritual items within it. As cracks appeared on the bones, diviners interpreted them as the gods' responses. Today, these artifacts hold immense value for historians and linguists, as they contain the earliest known collection of ancient Chinese script, which laid the foundation for the development of modern Chinese writing. Among the discovered oracle bones, at least 5,000 distinct hieroglyphs have been identified, though not all have been deciphered due to damage. To aid scholars in understanding the inscriptions, Tencent has developed an algorithm capable of decoding and reconstructing the ancient characters. According to the company's experts, since glyph interpretation relies heavily on their form, artificial intelligence analyzes the glyphs on oracle bones and compares them with images and modern Chinese characters. Artificial intelligence continues to advance rapidly. While some scientists focus on its use for decoding ancient texts, others have found equally intriguing applications, such as teaching computers to interpret animal communication. In 2017, young scientists from Berlin unveiled an AI capable of recognizing and decoding the dances of bees. Bees use specific movements, known as dances, to communicate the location of flowers to their hive mates. While previous attempts to decipher these dances were ineffective and required painstaking manual work, the German researchers fully automated the process using AI. The neural network employs cameras installed inside the hive and consists of 4 main modules. The first acts as a sensor, detecting the vibration frequency of the bees' bodies during movement, a key signal of the start of the dance, estimated at 13 Hz. Once the system detects this frequency, it marks the beginning of the bees' movement. The second module, closely linked to the first, filters out unrelated vibrations and analyzes 50 by 50 pixel image sets to determine whether the video truly contains a dancing bee. The third module determines the bee's dance orientation relative to the vertical axis. The fourth module compiles data from the other modules, decodes the polar coordinates of the flower's location, and determines its position. The system achieved a 90% accuracy rate in decoding bee dances, demonstrating the effectiveness of AI for studying animal behavior. For a long time, scholars faced significant challenges in decoding ancient Babylonian texts due to several factors. One major issue was that archaeologists often unearthed damaged clay tablets, with fragments of a single text scattered across various museums worldwide. Additionally, the texts were composed in 2 complex writing systems, Akkadian and Sumerian. Previously, working with Babylonian tablets was a painstaking and lengthy process. Scholars first copied the signs onto paper, then meticulously compared their interpretations with others to identify related parts and fill in gaps. However, thanks to a team of linguists and programmers in Germany, a computer program called Fragmentarium has fully automated this process. The AI utilizes 22,000 fragments of Babylonian inscriptions, previously digitized, to search for matching pieces in the database and connect them within seconds, subsequently translating the complete text. Fragmentarium has already successfully reconstructed and deciphered the Epic of Gilgamesh, the world's oldest surviving literary work, dated to 2100 BCE. The tool now has extensive work ahead with other Babylonian tablets. In 1973, during excavations at the Roman fort of Vindolanda, archaeologist Robin Burley discovered several wooden tablets that are the oldest surviving British written documents, dating back over 1,800 years. Over time, archaeologists continued to unearth similar artifacts across former Roman Britain, amassing a collection of over 750 Roman tablets, now housed in the British Museum in London. Some of these have been deciphered, and the most fascinating ones, along with their translations, are featured in the main exhibition for visitors to explore. The tablets contain handwritten records, such as military orders, complaints, invitations, and personal letters. The most renowned text among these ancient manuscripts is a letter from Claudia Severa, wife of North Fleet Commander Aelius Brocchus, to Sulpicia Lepidina, wife of Vindelander's prefect of the 9th cohort of Batavians, Flavius Cerialis. In the letter, Claudia invites her friend to a birthday celebration. Notably, the main text was written by a scribe, but the postscript was added by Claudia herself. The letter is dated to around 100 CE, making it the oldest document written in a woman's handwriting. Scholars have done meticulous work translating the tablets, though some remain undeciphered. To assist, British programmers are currently developing AI capable of automating the tablet translation process. The Voynich manuscript is considered the most mysterious book in the world. Named after Polish antiquarian Wilfrid Voynich, who acquired it for his private collection in 1912, the manuscript is a handwritten book with illustrations spanning 240 pages. Its enigma lies in its text, written in an unknown language, and its illustrations, which depict plants that do not exist on Earth. The author of the book is also unknown, with some speculating that it was written by extraterrestrials. Scholars have studied the Voynich manuscript for many years, yet its exact age and the text's meaning remain elusive. According to American chemist Greg Hodgins, who analyzed the manuscript's parchment, the artifact is approximately 600 years old. Many historians, cryptographers, and linguists have attempted to decipher the text, but all efforts have been unsuccessful. Some scholars have even speculated that the manuscript might be an elaborate hoax devoid of any meaning. However, the key to solving this enigmatic manuscript appears to be closer than ever, thanks to Canadian programmers from the University of Alberta. They developed AI for decoding the text. The researchers revealed that their algorithm, based on computational deciphering, was tested on 380 translations of the Universal Declaration of Human Rights. The results showed the system identified the language with 97% accuracy. Initially, the programmers assumed the book was written in Arabic using invented letters, but the AI disagreed, suggesting instead that the manuscript was written in Hebrew. This finding surprised the researchers, who nonetheless proceeded to investigate whether the manuscript contained any coherent meaning. Astonishingly, the program translated the book's first sentence, which read, "She made recommendations to the priest, man of the house, and me and people." Whether this is mere coincidence or a meaningful phrase remains uncertain, but it is intriguing. The Canadian specialists are continuing their work on deciphering the manuscript alongside Hebrew linguists, and perhaps soon the world will finally uncover the content of the most mysterious book. Many people believe that plants are incapable of communication, which is unsurprising given their lack of organs for interaction. However, modern scientific research has proven otherwise. While this information may sound fantastical, understanding how plants communicate requires acknowledging the many ways humans interact with the world, not only through speech, but also by seeing, hearing, smelling, feeling time, and sensing spatial awareness. Similarly, it has long been known that certain plants can emit substances to warn others of danger. Recent studies have also shown that plants can communicate with their kind, using impulses originating from their roots. To test this, specialists developed a program to send electrical impulses via a mobile phone, prompting plants to perform basic functions. Experiments conducted on the carnivorous Venus flytrap revealed that researchers could successfully make the plant open and close its trap on command. This discovery was groundbreaking, and scientists now hope AI will enable them to decode the language of plants. Thank you for watching to the end. Subscribe, like, and share.